Now on to question number 4. A 50.0 gram piece of metal at 305 degrees Celsius is dropped into 610 grams of water at 26 degrees Celsius. The water temperature rises to 28 degrees Celsius. What is the specific heat of the metal? So to answer this question, we're going to be using the following equation where Q is equal to mc delta T. So let me define what each variable means. Q is like the heat of the reaction, and it can be in joules or kilojoules, depending what is given in the question. M is the mass of whatever component you're focusing on, and it's given in grams. C is the specific heat capacity. And depending on the type of compound you have, it'll have a specific value. And its units are in joules divided by grams times degrees Celsius. And finally, delta T is the change in temperature. So it is T final minus T initial. Okay, so notice that they give us two different masses. We have the mass of our metal and also the mass of our water. And we also have the initial temperatures of both the metal and the water. So the metal was 305 degrees Celsius and the water was 26 degrees Celsius. And then after the metal was added, the water temperature changed to 28 degrees Celsius. So for part 1 of answering this question, we are first going to solve for Q that is gained by the water. And the reason why we're going to do water first is because the specific heat capacity of water is a known value. So I'm just going to write it up here. And its value is, it's cut out. So the specific heat capacity of water is 4.184 joules over gram times degrees Celsius. Okay, so this value is known, and that's why we can just use our equation to solve for the Q, or the amount of heat that was gained by the water. So the mass of water was 610 grams. The specific heat capacity is 4.184 joules over gram degrees Celsius. And finally, when we look at delta T, the final temperature of water was 28 degrees Celsius. And initially, the water was 26 degrees Celsius. So now if we multiply these values out, you end up getting a Q of 5,104.48 joules. So this is the amount of heat that was gained by the water. And now let's recall that heat is lost by the metal. Because some of the metal's heat was transferred to the water, that means heat was lost by the metal. So therefore, its Q value will be negative. So when we move on to step 2, which is finding the specific heat of the metal, it's going to have the same value of heat that was lost by the water, or that was gained by the water, except this time its value is going to be negative. So Q is equal to negative 5,104.48 joules. And now we can just plug in all of our variables for the metal this time. So the mass of the metal was 50 grams. And we're trying to solve for the C. So C of metal is unknown. And finally, for its temperature difference, we have the final temperature as 28 degrees, and the metal's initial temperature was 305 degrees Celsius. So now let's try to solve for our unknown. If we divided 5,104.48 by 50, and then by 28 minus 305, we get a specific heat capacity of the metal equal to 0.369 joules over grams degrees Celsius. Okay, so now let's see what the junior tutor said. In order to solve for the specific heat of the metal, the first thing that we need to know is that the quantity of heat gained by the water is equal to the quantity of heat lost by the metal. This heat gained by the water is calculated using the following equation. Q equals mc initial final temperature minus initial temperature. And then they just defined all of the different variables. From the given above, we can solve for the heat gained by water, and they also got 5,104.48 joules. So since this is gained by the water, therefore this is also the quantity of heat lost by the metal, and it's going to be a negative value. So using the same equation from above, we will now compute for the specific heat of the metal, and they also got 0.369 joules over grams degrees Celsius. So the solution is correct.